Half a day. This is going to be the first video of 2 on decimals. In this video, we'll be going over place values, estimating and rounding, addition and subtraction, multiplying decimal numbers, and then multiplication of decimal numbers by 10. So firstly, when we talk about decimal numbers, we have to keep in mind place values. It's similar to how we did place values with whole numbers, but now we still have that whole side. So for example, with the hundreds, tens, ones, but now we are including the decimal point as well as decimal places, which are to the right of it. When you're reading out or saying out loud decimal numbers, there's 2 different ways. For example, this first one, 0.38, that's one way to say it, where you just say point to indicate that there's a decimal point. Or you can say 0 and 38 hundredths. We indicate what the last place value is, and then just have that number and say how many hundredths. For the second one here, we can say 21.925. 5 is the third place value after the decimal point, which is thousandths. So 21 and 925 thousandths. 4.0006, that'll be in the 10 thousandths. So 4 and 6 ten thousandths. 0.5 or 0 and 5 tenths. What I also wanted to share is that decimal points, the reason why we say tenths, hundredths, thousandths, is because they can be represented as fractions. So that point in the thing, it's actually going to indicate how many zeros are in the denominator when you have a fraction. So we're just putting it over powers of 10. So 0.38, we said that was 38 hundredths. That's actually 38 over 100. Those 2 zeros are how many decimal places there are. So 38 hundredths. 21.925, we have 21 plus 925 thousandths. So 925 over 1,000. 4.006, again, that is 4 plus 6 over 10,000. I have 1, 2, 3, 4 decimal places and 4 zeros. 0.5 we know is going to be 5 over 10. And we know that one is actually 1/2, right? So that simplifies to 1/2. But that just gives you the origin of why we say tenths, hundredths, thousandths. They represent fractions. Estimating we'll do the same way that we did when we talked about whole numbers. So 473.28 rounded to the tens value. Notice that that's tens, there's no th. That's not going to be the decimal point, it's going to be the 10 value. So like hundreds, tens, ones. So I'm going to round it to that 7's place right there. So I'm going to look always to the one to the right of it. The 3, since it's less than 5, that 7's going to stay the same and everything to the right will be zeros. So it's 470. For letter B, we want to round it to the 10th place. So that's going to be the 2. And again, we want to look to the right of it. That 4 is still below 5, so the 2 is going to stay the same. 3.2. Letter C, the 100th value is going to be the 8. So 2.485 directly to the right is a 5. So 5 or greater, I'm going to increase that 8 by 1. So it's going to be 2.49. 64.9828 to the 1,000th place. We have tens, hundreds, thousands. So the 2, the 8 next to it is going to raise it up to a 3. 64.983. Down here, you might also see they'll round it to a certain number of decimal places, and that's going to be anything to the right. So the decimal places, I actually want to stop at 8. To the right of it is 3, which is less than 5, so we'll have 4.98. So rounding exactly the same, and we're just dealing with recognizing what place we're talking about. And I just want to add one last one here that I don't have typed, just because it is important. So when we talk about rounding to a certain decimal place, let's see, for letter F, 3.9996 to 3 decimal places. Okay, so I already know I'm going to round it to that 9. The 6 to the right, we'll change it to a 10, which gives us a 0. So that's actually going to be 0. Then I'll have to carry that 1 there. So that 9 actually becomes a 0, 2. I have to carry another 1. That'll become a 0 also. Carry one more time. 4.000. So that one place value made us go up, which made everything else go up by 1. So 4.000. And since it does say 3 decimal places, you have to leave those 3 decimal places. So even though there are 0, and typically when you're dealing with decimals, a 0 at the right side doesn't matter after the decimal place. But for this one, you do need it. As we go into addition and subtraction, you really only need to remember one thing, and that's just to align your decimal points. So we're aligning our place values by aligning our decimal points, and then adding or subtracting normally. In this first one, okay, so we're going to set it up, 75.4 plus 186. Since 186 has no decimal point, it's understood to be at the end of it. If it's a whole number, the decimal point's at the end. So 186.0, so 186 is right here. You can put that 0.0 just to help it, so that you're not confused. 0.56, 0.56, 2350. Again, the decimal point's at the end, 2350. Oops. And again, I usually like to just fill in zeros. You don't need to, but I like to, just so I'm not super confused. Okay, now we just add down. 0, 0, 0, we have a 6. And this next one, 4 plus 5, 9. 5 plus 6 is 11, carry the 1. 8 plus 8, 16 plus 5 is 21. 2 plus 1 plus 3 is 6. Then we have a 2 right there. 2,611.96. For letter B, we'll do the same thing, align it up according to place values. 12.6 times or plus 3.24 plus 1.207. Again, I'm putting these zeros right here so I don't get confused. We have 7, 4, 6 plus 2 plus 2 is 10. Put that decimal point right there, don't forget it. 1 plus 2, 6 plus 1, 7. 1. 17.047. For letter C, we have 840 minus 236.22. For ones like this, when we have subtraction, it is important that we put those extra zeros at the end. So I know that's there, minus 236.22. So when we are subtracting, we do need to put those zeros there so that we know what to subtract from. So 0 minus 2, I'm going to have to borrow. So we have 10. This is going to borrow again, so that's going to be 9. This is going to be 9. and this is 3. 10 minus 2 is 8. 9 minus 2, 7. 9 minus 6, 3. 3 minus 3 is 0. 8 minus 2 is 6. 603.78. And for this last one, we see that it says subtract this number from 187.5. So 187.5 is actually going to be on the top because I'm subtracting 2.093 from that. So 187.5. Be careful when you're setting up these times because a lot of people mix up. They'll put 2093 minus 187.5, but it's the other way around. Filling in those missing zeros. 10 minus 3, we're going to have to borrow. So this becomes 9. This becomes 4. 10 minus 3. 9 minus 9, 0. 4 minus 0, 4. 7 minus 2 is 5. 185.407. Same thing as whole numbers, we're aligning it, but now we're adding in those little zeros where they need to be. We call them placeholders. It's holding the decimal place. Now we'll move on into multiplying decimal numbers. What you're going to do is align from the right with the number with the most places on top. We're going to multiply it as if we're multiplying whole numbers. We're multiplying normally. And then at the end, all you're going to do is count the total number of decimal places in the factors, so in both of the numbers you're multiplying. And we're just going to put the same number of decimal places into our product. It's easier when we have an example, so we'll just start here. 0.035 times 0.25. I'm going to put the one of the more numbers on the top, so 0.035 times 0.25. So I don't even really care about the decimal places right now. I'm just multiplying normally. So we have 5 here, 5 times 5, 25, 5 times 3 is 15, plus 2 is 17. You can put the zeros there if you want, doesn't really matter. Put a 0 here, start with 2. 2 times 5 is 10. Carry the 1. 2 times 3, 6, plus 1 is 7. If you want, you can put zeros at the left side, you don't really need. 5 plus 0, then we're going to add down, right? 5 plus 0, 5, 7, 8. Now what I need to do is count how many decimal places. So for this one on the top, we have 1, 2, 3 decimal places. Then we have 4 and 5. So I'm going to count from here. 1, 2, 3, 4, 5. Place a decimal point right there. 0.00875. For this one here, for letter B, we have 4.6 times 3.749. Even though technically 4.6 is the bigger number, I'm going to put the one with the most digits on the top. Okay, 9 times 6 is 54. 6 times 4 is 24, plus 5 is 29. 6 times 7, 42, plus 2 is 44. 6 times 3 is going to be 18, plus 4 is 22. Have a 0 there. 4 times 9, 36. Carry 3. 4 times 4 is 16, plus 3 is 19. Carry the 1. 4 times 7 is 28, plus 1, 29. 4 times 3 is 12, plus that 2 that we carried over is going to be 14. Add down 4, 15, 14, 12, 7, 172454. Count the number of decimal places. 1, 2, 3, 4. 1, 2, 3, 4. So it's going to be 17.2454. 0.00854. For the left one, it should be 0. I need to write it. 0.00875. We always just want to box our answers when we're giving it. Now we'll move on to the last one, which is actually just going to be a special case of multiplying decimals. When we're multiplying decimals by powers of 10, when I say the powers of 10, it's either 10 raised to 1, 2, 3, 4, or 10, 100, 1,000, a million, things like that. So what you're going to do is count the number of zeros in the power of 10, or if it's like 10 raised to 4, we'll just use the number there, so the 4. Then what we're going to do is move the decimal point to the right that many times. So if we have 5.3 times 100, I know I have those 2 zeros there. So I'm going to move the 5.3, I'm going to move that decimal point 2 times to the right. 1, 2. So I'm going to end up with 500. For letter B, we have 0.0973 times 10 to the third power. So 10 to the third power is 1,000, but if you have an exponent of 10, you'll just move that number of times. So when we have 0.0973 times 10 to the third power, I'll just move it to the right 3 times. 0.0973, 1, 2, 3, and I'll just rewrite it so it's nicer. 97.3. Up here at the top, we have 12.0567 times 10. There's only 1 0 there. I'll move it to the right 1 time. 120.567. And in letter D, you can see that it also works when the multiple of 10 is in the front, so it doesn't really matter. But I am going to move the decimal point on the 2. So I know it's at the end, and it's going to move 4 times. 1, 2, 3, 4. And I'm filling in these zeros. So it's going to be 20,000. And that is it for this video. I will be following up with another video on decimal numbers, but try to work on these for now. Hopefully we all learned something. It may be new, it may not be new. If it's just a refresher, that's great too. Anyways, that's it for this video. Good luck, have a great day.